Welcome back to the Roll-Up High Roller community. As always, nothing on the roll-up is to be construed as financial advice. We are just some educators in the DeFi space. Toss us a quick like, give us a share, a repost, send it to a friend who may want to watch this, and finally, give us a sub or a follow. It means the world to help support credibly neutral educational content in DeFi. We're here to educate, empower, and enrich you, and let's jump in.
Welcome to DeFi by Design, where we talk all things blockchain and cryptocurrency while striving to educate, empower, and enrich.
What's going on, guys? Welcome back to episode 117 of DeFi by Design podcast. Today, we're going to 100x lower the cost of roll-up transactions, and I couldn't be more bullish, boys. Look at that smile. I'm Prabal. I met Prabal out there in Istanbul, so did Rob. Had a good time, got a sick Avail shirt. I'm not wearing it, unfortunately, but I still got it in my suitcase. Haven't made it home yet. Things pretty fresh. Rob, how you feeling?
I'm doing good, man. I'm feeling good. It's it's good to settle in after the conferences. I mean, the conferences are a whirlwind. Kudos, and you've been riding the momentum. Just got shot out of a cannon at Istanbul, and just hasn't been the same since. So we're pushing on all fronts, learning so much about modularity, and we're definitely going to be going through the modular stack today. And I think just as we kind of like start to get into it a little bit, we can almost start to frame this mental model where like the stack concept originates from like the layer 1, layer 2, layer 3, and so on and so forth. And it is very clear, like the mental model is very, very, very clearly a stack of these different technologies on top of one another. And then they all kind of flow data down to the base level where it settles on chain. Modularity blows this all up. It's like totally unpacking all of these components and just sifting them all throughout space, all over the universe. And then there's so many ways where we can connect. We can plug in, plug out different things, choose where we want to combine certain technologies for different flavors of an application or a blockchain or several use cases from there. So Prabal, I'd love to start with what your mental model is, where you view the general, like how you view this general space. What is your mental model?
Yeah, I think the mental model stems from what we have seen till now, like the status quo, where we have seen that a lot of different activities are happening on the base layer on a single layer. What that means is we have, tried very hard and for very long to kind of scale this one single layer to make it compatible for doing a lot of these computation, a lot of these bootstrapping of security and so on and so forth into a single monolithic layer. And then we realized that the monolithic world doesn't scale because you cannot optimize all the parts of it without breaking the main layer itself. Because it's monolithic, any part you want to change, you have to make a protocol layer change onto the base layer, which is completely infeasible. For example, if there are many new different ways that MAB can be rectangle for the users, right? So there has been a lot of novel work which has been done for, let's say, a mempool which is secured by MPC, or there is a commit release mechanism on the mempool, and so on and so forth. All of this is great. A lot of research has been done, but most of them cannot be implemented on a monolithic design because you at that point have to change the entire mempool for the base layer, and that affects all the applications running on it, right? And you do not have a choice at that point because it's a single layer. What modular and the entire thought of roll-up centric roadmap like we have seen actually says is that you can now take bits and pieces of it, put it off chain, and then push something very succinct on chain, right? And then the on chain demands remain very, very minimal. The base layer acts only as to so-called give the security, right? And minimal things like data availability and settlement. Whereas everything else, the complete execution, the complete mempools, the ordering, can be done completely off chain. So that's what this entire shift in mental model kind of feels like. What that also enables is that individually, each one of these pieces can be optimized, can be made to be custom. Uh, for example, simple things like, do you really need the entire EVM architecture for your application specific rollup? If the answer is yes, then that's great. You can just inherit that transactional structure, the state and storage structure, the state transition function, and so on and so forth. But if not, you can now do custom states, custom transactional structure, custom storage layouts, and so on and so forth. So with what this essentially feels like, and sorry for the long-winded answer, but the entire mental model feels like, how you would start with a single layer, try to consolidate, like when I write a code base, I start with something that just works. Something might not be broken into functions. Things are all, into a single main function, which contains all of that code base. And then that lets me get the work done, right, in the first iteration. But then as you want to make things much better, more optimized and so on, you take pieces of the code base, make it into functions, keep abstractions, you slowly try to optimize bits and parts of it, because then your code becomes overall more optimized. And that's what at least my mental model is like.
Yeah, and I appreciate the long-winded answer because, frankly, up until 4 months ago, I was quite confused on what this even meant. I remember being at HCC, there was Modular Summit, and there was like some other L2 event, and I was like, that was back in July. I was like, Modular Summit, who wants to go to that? Whatever, what does it even mean? And then now it's like the whole crypto world's talking about it, and I think that I'm still getting a lot of questions with regards to what is even the basic stack. So I'm glad that we've established your foundational view. And I think it's, again, in alignment with a lot of what the general consensus and thought processes are around the advantages. So now building off that, and I'd like to deep dive into each layer, into DA, but just continuing to build off this foundational, kind of overlook. We now have this idea in a lot of really smart builders' heads who've raised money, who have good teams and are building this tech. So now what does this modular future based on this foundation look like 6, 12, 18 months from now? And then how is that different from what it looks like today? And you're on mute, sir.
Sorry. And how it looks like today, especially let's talk about the Ethereum ecosystem, right? How it looks like is that whenever there is a lot of activity, the price activity becomes extremely expensive, right? It gets very hard to use the chain because all the activity hits that same layer. And the fact of the matter is that as and when we get more and more use cases, more and more applications, this is unsustainable. To be able to give, one transaction fee as tens of dollars to even spiking up to hundreds of dollars is not sustainable for a use case specific blockchain. If we want to make blockchains mainstream, in the modular world, what will happen is that this is going to become rollup centric. What this means is all that execution will be completely taken off chain and be done with. Users will get sub confirmations of that transaction acceptance. They would be happy with it. They will be formed of batches, and then the batches will only hit some of the DA layers, and the proofs will hit the settlement layers of the world, right? So, in that kind of world, is where we will be able to see amortization of cost. Not only it's about just the cost, it's also about the user experience, right? Now, different layers have different block times, block finalities, and so on and so forth. So even, for example, today as a user, you have to wait for like say 12 seconds for Ethereum blocks, and if you want finality, you have to wait for 12 to 15 minutes of finality, right? So in this kind of world, depending on what kind of guarantees you need, you have to wait for different amounts of time. For example, if you want soft confirmation, you will get it in milliseconds. For example, I think Arbitrum today gives somewhere around 500 milliseconds or maybe even lesser times of transaction confirmations, which is great to have, right, for a user. You just give it, and it feels like a Web2 kind of an experience where you just submit a transaction, you get back a confirmation that it has been accepted. But if you are maybe transferring a lot of funds, let's say I'm sending millions of dollars, then of course I wouldn't only do that on the transaction confirmation, the soft confirmation, right? You would want to have subjective finality or objective finality. In terms of subjective finality, you have to wait for this batch to hit the DNA, which then encapsulates the ordering of the transactions. And after that, you might even want to wait for objective finality, which can be a few hours to a few days, depending on whether it's ZK verified or optimistic construction, and so on and so forth. So you see the options for the users increases a lot, right? So the experience changes a lot. The abstractions and the optimizations and the customizations, they all change a lot. And that is what this entire roadmap is about, to be able to give different kind of experiences depending on the use cases to the end user.
Yeah, I've wrote a lot about, and I've got it here as DA equals 100x cheaper transaction cost, which is something that I'm really excited about. I was at Epic Infra Day in Istanbul, and the founder of Near was there. Of course, they're working on a DA layer, and I asked him, like, is this going to allow rollups to have transactions that basically are unfathomable in costs to what is current? And he was like, yes, like this is something that people aren't really understanding as far as how much lower this is actually going to cost. And then in addition to that, you spoke about this idea of confirmations and this idea of pre-confirmations. Is it correct that using a DA layer will actually increase the time to get a pre-confirmation of a transaction, or is that not true? Like it'll make a pre-confirmation quicker rather than going through Ethereum as a DA layer, or no?
The main thing about modular is that there is no straight answer, which is sometimes not kind of taken up nicely, right? But the fact of the matter is it depends. It depends because if you are using a centralized sequencer, the transaction confirmation times will not change at all, because your confirmation is going to come from the sequencer. The entire experience is going to remain the same. If you are thinking about the confirmation coming from the DNA, which is the subjective finality that I was talking about, the subjective finality might take longer, might take shorter. It might take shorter because, you might not be able to fit a big batch into one block of Ethereum, right? So when you're unable to fit bigger batches, you break it down into shorter batches and you push it onto Ethereum, which will keep on increasingly seeing. We see some of it today, but as demand increases, we will keep on seeing this kind of trend. Whereas DA-specific layers, they have the capacity to take in a lot of bigger blocks. And then it might be longer because there are other constructions called base rollups. In base rollup constructions, you do not have a sequencer, right? You directly send it to the DNA. And then depending on the DNA uptimes and so on, it might take a bit longer, right? So all of that is based on orientation. It is based on what kind of confirmations are you looking for. Then there are very, very normal constructions which are coming up, which we will keep on seeing in the near future, things like shared sequencers. So if you're thinking of a cross roll-up interaction, the kind of confirmations which a shared sequencer can give you is probably like orders of magnitude faster than what you could have done in any of the other configurations, right? But again, is that needed? Is there supplementary constructions which can allow it? Maybe yes, but that's there too for us to see, like for us to check it out when those kind of infra things come together, and then only you will be able to see the benefits. But largely, to answer your question in one word, the answer would be no, because today the status quo is centralized sequencers, and they just give soft confirmations from them. The DA layer and the settlement layer is completely abstracted out from the user.
Yeah. So for the sake of the conversation of abstracting away edge cases, and also focusing on what is today, the big upside for using DA layers is to find this happy medium between security and decentralization, whilst also lowering costs significantly for rollups. And then when it comes to the speed, this is something that is kind of a case by case specific basis. Now, Rob's got something, but I just want to add the last thing onto this one is, so if my confirmation times on Arbitrum and Optimism and various other modular rollups, I think you met us at like 600 milliseconds. Let's call it 500 to 700. Solana's 200 milliseconds. The UX is great. When I onboard friends to Solana, they love it. Why would I even think about using a modular rollup if I can use Solana?
Yeah, I think, again, like every construction does trade-offs, right? So if someone is saying that there is no free lunch, right? So every construction makes trade-offs, and that's what we should appreciate as well. And that's why I don't want to say that, don't use Solana or something like that, because if a user is happy with that experience and people are building like very good use cases there, then of course it's a thing to kind of study, to understand what the trade-offs are, to kind of keep on using it, because we all want more and more use cases in the blockchain ecosystem. We don't have enough of it. And if someone like Solana can help us bring those use cases, then we shouldn't criticize it just because we cannot so-called compete with the block tiles or whatever, right? Now, the answer to that is verifiability, right? So it's about the end user verifiability, which is something which is very close to the Ethereum ecosystem. And that's what we also want to do as far as Avail, and you will see all of the other efforts in this community is towards the end user verifiability. Now, if you think about the trade-offs there, we want the end user to be able to verify whether the transaction was done correctly or not. In Avail, what we are trying to do in that regard is that we are enabling data relative sampling, which is a powerful construct in which users can themselves verify the data availability, rather than relying on any blockchain that whether it is available or not. And we are also kind of trying to do things like wallet level ZK verification. What that essentially means is, if you think of the end user experience and how we look into the world right now, or at least how we envision that the world will be, is that the users will actually get proofs of execution and will do sampling to get proof of data availability. With these two constructs, they can be extremely sure and self-verify that the transaction was done correctly and that it is included and it cannot be changed. So this is the kind of end user verifiability that we want to give as part of what we are building in the DNA, but also what this will enable in terms of, if someone is using, let's say, a ZK stack for generating or for processing the transaction. So that's the kind of trade-offs that you are taking. It's about verifiability versus, faster block times and things like that. But again, you will keep on seeing much smaller block confirmation times. Like it will almost feel like a web to API call at some point in time, because the sequencers can do very, very fast confirmations. It is down to what the trade-offs are right now is that, is it sustainable, right? Is it sustainable to keep on growing a chain at the same time keep on giving faster confirmation times, right? So for example, when I receive a transaction, do I just give you a confirmation that it is accepted, or do I process it and then give you a confirmation of it accepted? When I say I process it, how long do I take to process that transaction? That, if you are talking about an Ethereum-centric rollup, which has a lot of state blocks, then that can be a bit costly, right? Because it has a lot of things to pull from the state, a lot of IO fetches, which are harder to optimize on. And then if you talk about custom state transitions, and that's why I was mentioning that a bit earlier, we will keep on seeing that with custom state transitions, with very, very lightweight app rollups, it will almost feel like a Web2 API call, because all of that already happens in Web2 API calls as well. As soon as you make a call, it does some verification, some internal checks that it is correct, and then gives you a fast confirmation.
My body is ready.
And these are all trade-offs that builders are making, like as they build these rollups. And you mentioned that you're building Avail for user verifiability. The reason that you prioritize user verifiability sounds like something that I heard all the way back from Satoshi's white paper about people running a full node. So I think that's a very noble cause, and it is important because we've seen we've seen why not your keys, not your coins, why that holds up. Is it? And I take it that the data that is going through each user's transaction is very, very similar and core to the like native experience about of them running this node. So they're not running a full node in these cases, but they are processing the data themselves. Could you kind of like describe why data availability is important, like at a first principles level, like the user verifiability that you're enabling, what does that enable for the end user?
Yeah. So on that, I think you made a very good reference to the Bitcoin paper, and let me just try to talk a little bit about what that enabled and what we are enabling, because it's not a apples to apples comparison, and that's why I want to clearly state what the value prop is. So on a Bitcoin kind of a node, or even in Ethereum, the chains are actually doing execution, right? So the entire world computer vision of Ethereum that was there. So essentially, you can think of it as like an execution machine which you can trust, so to say, right? Because it is secured by the crypto economics of Ethereum's validator set. In that kind of a world, you have to run a full node to know whether the execution was done correctly. Even if you're an end user, what you do is you do not rely on the 2x3 plus of Ethereum or the 51% of Bitcoin. You basically run a full node to know whether they did their job correctly. That's the kind of verifiability I'm talking about, right? So that's why you have to run a full node to know whether it was processed correctly. And then there are concepts like social consensus and social thoughts, right? Even if they collude, even if 2x3 plus colludes and actually processes the wrong transaction, your full node will actually fork off. It will not accept that block. It will not accept that block just because it has enough attestations from the validators. That's the power of these constructions. In a data availability focused chain, what we want to give is that we want to give the ability to the light clients to verify data availability. Mind you that the core focus of execution-based chain like Ethereum is doing the execution. On Avail, it's only about data availability. And we want the light clients to be able to verify data availability without relying on the 2x3 plus of our chain, right? And that's the value that we want to add to this system. Now, what that collectively means is that as a user, as I mentioned, you need two different things. You need executional correctness and you need data availability. On the data availability front, we are allowing light clients to do extremely cheap data availability sampling, only perform like, let's say, 15 to 30 data samples, check it for correctness, and then be very sure that the data is actually available. We have a web page which can do it on a mobile browser, right? So that's how easy it is to be able to actually do data availability sampling. And on top of that, all you have to do is verify a ZK proof. A ZK proof, depending on what kind of proof systems and so on, might take about 60 milliseconds, to kind of verify, right? And you can understand the power of this construction. Like in order of milliseconds, you not only know that the execution was done correctly, but also the data was available. This is a big shift from, I think the AI is also understanding that I'm saying it right, but this is a big shift from crypto economically driven chains to cryptographically driven chains, right? So in essence, you had chains which were secured by crypto economics because you had to rely on the 2 by 3 plus in order to do it correctly, or you have to run a full node to verify. Now you're just relying on the 2 by 3 plus on ordering, and the rest, everything you can verify on your own. You can verify the data availability, but you can also verify the execution correctness.
Yeah, and our audience probably already knows this, but the reason that it's so quick to check these ZK proofs and why this cryptographic verification is possible is because ZK proofs are it's almost impossible to come up with the solution, but once you have the solution, it's very easy to check and make sure that the solution is correct. So that means that it's almost impossible, right, to make that proof, but once you have it, you can do it in 60 milliseconds. You can check that, you can verify that proof is correct. Okay. Yeah.
Sorry to interrupt. I would like to frame it a bit differently and say that once you do an execution, you basically want to create a proof of correct execution. Making the proof is somewhat very hard, right? So what you do is you do a lot of this. I'm not going to the ZK cryptography side of it, but basically, depending on smart, you create those circuits or the AI representation and so on and so forth. You basically allow the prover to do a lot of work. After doing the lot of work, you then give a succinct proof to the verifier, right? And then I'm saying ZKP, and basically I'm abusing the terminology. It's a succinct proof and so on and so forth. It's a snark, things like that. But again, I'm not going into all of that.
The user can use that succinct proof to verify the execution.
Exactly. The complete execution can be verified.
Yeah.
Got it. Okay.
Again,
and then
I'm sitting there. Yep. Go ahead, Ron.
One step further, and then yeah, I'm sure Andy's biting at it. So then we get into data availability sampling, and could you talk us? And I heard one of Vitalik's talks at Istanbul, and he was all over this data availability and data availability sampling. He described like one-dimensional sampling and then two-dimensional sampling, and how these were a couple different methods, and I'm sure there's trade-offs for using different methods of sampling. Could you describe, like, once we understand, this user verification, how is data availability sampling related? And then why might someone choose to go with this one-dimensional approach versus this two-dimensional approach?
Yep. I think it's an interesting topic to kind of discuss, and thanks for asking this kind of questions. So essentially, one of the powers of data which compute doesn't have is the ability to be able to efficiently sample it. Now, what I mean by that is, when I take some data, I can erasure encode it. I can essentially create redundancy in that data in order to make it extremely hard for someone to hide parts of it. And an analogy I like to give, which might not be a perfect analogy, is that if you had compact discs, I'm probably sure that you guys have access to it. I don't know how many of your listeners have used it, but if you have compact discs and there was a scratch on top, you could still play the video or the audio file which it contained, right? And the ability for that to happen is because this was erasure coded. So there was a lot of redundancy in place, so that even if bits and parts of it were missing, the rest of the computer can actually take in the missing parts and reconstruct it, right? We are using this in the flip side. Because we are now making it harder for someone to suppress data. Now, mind you that if someone was able to suppress data, then all of this roll-up that we are talking about their security with usability or actual security, depending on how you define it, actually completely falls apart. If you're able to hide parts of it, then in an optimistic design, you can't even construct a fraud proof. So it completely breaks security. Even in a ZKP kind of world, like, you're creating validity proofs and so on, if you have the data kind of missing, then your liveness gets compromised. So users' accounts might get frozen and so on and so forth. And that's why we have the data availability, the data availability constructions where we add redundancy to this data. We add redundancy so that it becomes very hard for someone to actually hide parts of it. Now comes the one-dimensional nature versus a two-dimensional nature of it. Like how you actually construct this data availability block, right? The block of data. Now, in one dimensional, again, depending on what kind of construction that you use, whether you use a polymer commitment based like we use, or a hash based like some others use, there are different ways in which the data remains secure. Right? In a polymer commitment based scheme, we are essentially making trade-offs. The trade-offs are how long does it take to create a commitment, how long does it take to generate an opening, and how long does it take to verify an opening. What I mean by opening are the sample proofs. So essentially, when you ask for a sample, you essentially choose a small section of the entire data and say that give me a cryptographic proof that this belongs to the commitment that you gave previously. And then the network has to generate that proof and then give you the proof. You then have to verify the proof. Right? So this is one angle to it. The second is how much redundancy are you adding? How easy is it becoming for someone to verify whether the original data was available or not? Right? How many samples do I need to do for me to be able to get a very high confidence that the actual data is available? These are the kind of trade-offs that you are making. There are some other trade-offs in some other constructions. Like, for example, if you are a fault-proof secured system, then essentially, if you create, like, how big is your fraud proof? Is your fraud proof efficiently verifiable by the light client? You cannot expect a fraud proof to be so hard to check that it essentially needs a full node to run, that it completely defeats the purpose of creating a light client, right? So in essence, what I'm trying to say is all the construction categories, kind of parameters, and the construction, the design is a big trade-off on how much verifiability you want to give, how much of it is being offloaded to the generator of the block production engine, that is, how much of that is being pushed on to the end user to be able to verify, and the proof sizes, and so on and so forth. So I don't know whether I was able to capture all of it, but hopefully that gives some ideas.
Yeah, essentially, based on the size and the level of, I would assume, the level of security needed by this specific use case, one could assume for something that's not super financially related, you could use, a potentially a smaller or less sophisticated system, but something with it that has a lot at stake, something a bit more, rigorous. That kind of dictates the design choice of the type of data delivery simply which you would execute. But it also, the amount of data also has to be basically, it has to fit like a Lego piece in a sense to be able to actually be operated by light clients, so that they could actually, just do their job, which is what they do best, which is, instead of spending a ton of basically economic value on verification, we're able to cryptographically prove that based on these randomized proofs that this entire blob of data, for lack of a better term, is accurate. And I'm starting to realize a lot of this modular blockchain stuff, especially with DA, it's about not giving into the typical trade-offs that would come with just using Ethereum as your DA layer, which comes with a lot of costs, but you get that, really high level of security. But it's finding where you can kind of mitigate the trade-off of security using something like a light client, cryptographically proven proven blobs of data for that, for the DA layer, but then also then by doing that, you get that exponentially lower cost on the flip side. So it's almost like we're like reshaping trade-offs here in a way where we're trying to find the exact right formula to make it the best of both worlds.
Yeah, that is true. And I think it has to be understood that Ethereum is by themselves in a DA-centric roadmap, right? So they also want in its final shape and form, want to be a DA layer. And that is the trend that you will keep on seeing for many base layers. You have started seeing many L1s, or at least one or two of these L1s trying to be a DA layer, because you will keep on seeing this trend. L1s will either start becoming N2s, we have already started seeing that, and L1s start trying to becoming data availability. Because in order for a base layer to be able to scale, they have to be a DA layer, because the DA is the only thing that scales. Compute doesn't scale in a similar manner, right? So that's the kind of trade-off that you will keep on seeing. On the other hand, like, it's very important to kind of understand where the cost reduction comes from. It should be very clear that this is not a alt L1 kind of a thesis, right? That, I had Ethereum, I create a clone of Ethereum. Of course, the clone of Ethereum is going to be cheaper, so just use me because I'm cheaper. But you have you don't have activity. Once you have activity, you become exactly the same amount of cost that Ethereum gives you, right? So there's a lot of thesis like that, and I want to make it that clear, because often people mistake it like that. Right? The actual cost optimizations comes from the actual code base. If you make a system optimized for a specific job, of course it will be more performant, and hence it will be cheaper. Ethereum started off with a very computation-centric roadmap, and only now it is trying to shift towards a DA-centric roadmap. Because it is inefficient for handling DA, you are seeing today like $1,300 to $1,600 or even beyond for a single MB of call data. And that is because that was not optimized for DA. And Avail is cheaper, not because it doesn't have activity. Of course, it's not in production, so I cannot talk about actual numbers and transaction cost. That would be foolish for me to do. But it will probably be orders of magnitude cheaper because it's orders of magnitude more efficient at handling DA. Right? So that is a clear demarcation that I want to make, so that it becomes very clear to the end user that what this thesis looks like, that we are a scalable DA layer. And the other thing which people fail to understand is that the superpower of DA is that it is able to scale to a bigger block if the demand increases. That's almost never possible in a computation-centric mode. So, for example, if I see that in a typical blockchain, if I see that my blocks are getting filled up, I cannot double my space, because to double the amount of computation, I need double the amount of resources for the validators. Of course, we have seen those kind of chains where validators are extremely beefed up in order to give high TPS, high numbers, and that's okay. That's also okay. Because who am I to make that trade-off if that's a utilizable chain which has a value prop by itself? But what I'm trying to say here is that DA layers can actually make their blocks bigger without incurring a double cost on the validators, because the verifiability depends on the amount of light clients and the amount of utility. If the utility increases, that's more people are using it, then more light clients will run. And when more light clients run, then you can have bigger blocks. And that's extremely novel in this use case, which none of the other kind of monolithic chains can give you.
Yeah, I appreciate that. That was well over our head with regards to the differences between computational focused chains versus data chains, but that actually makes it much more understandable as to like why something like just simple chain like an app chain on Cosmos or even some of these other potential DA layers are able to then scale effectively. What you're saying is, you can't just spin up another chain that has no activity and be like, look at me. And this has been something that I've been focused on when in my writings recently, which has been the value accrual thesis for this world. So we've been talking about a lot, and I'm very bullish on DA because of all of this last 10 minutes of conversation. But one thing that's interesting is this transition from Ethereum, from a computational heavy roadmap to now a data focused roadmap. And I feel that it comes out of fear. Why do I feel that it comes out of fear? Because I feel like Ethereum is somewhat threatened by the modular thesis because of the removal of its importance at the DA and at the execution layer. I find it hard to refute Ethereum as the main settlement layer. I think that Ethereum-based rollups at a settlement level, it's hard to argue that there's XYZ L1 that can be better, and perhaps you have an answer for that. But is there a sense or a smell in the air that the modular thesis, replacing EVM or using alternative VMs as well as using alternative DAs could be a problem for the speculative, or perhaps just for the value accrual of Ethereum in the future, and perhaps some of that value which may accrue could accrue to these modulators? I'm kind of setting you up here, but this is something that I've been kind of thinking about.
I think there are two ways to answer this, right? And I will try to be politically neutral here by mentioning both these use cases, both the ways. And I truly believe that there are both sides to the story, right? On one side is the dominance of EVM. The dominance of EVM is pretty clear right now. But my bet is that it will be broken, not because EVM is not good, but because there will be use cases which can move away from EVM and will be able to thrive. EVM doesn't allow all kinds of operations that a rollup would want or an application would want. And we are already seeing that as part of our exploration team. We are trying out different use cases which were not possible in an EVM-centric world. And we are very bullish on the app-specific rollup kind of thesis, right? Where we believe that people are going to, run a lot of these applications. Many of them will be custom. Many of them will inherit the best of many, many worlds, which we have seen. You have seen things like Aptos and so on. You have seen Solana and the SVM. We have seen EVM, but we have also seen things like risk zero-based VMs, which are like just ZK verified of any state transition function and so on and so forth. And there are many good players which are coming in, which are making really good headways in terms of like this pool, right? Which has a very novel structure in terms of the virtual machine and so on and so forth. So that is something that we will keep on seeing. So the domination of Ethereum in terms of the Ethereum virtual machine is probably at risk. And yes, there might be a fear that other things will take over. But that doesn't mean anything for the Ethereum, because Ethereum wants to move away from the execution layer. And EVM is just the style of execution there. The second thing is the Ethereum user or the liquidity or the value base, right? So Ethereum is already looking to be ultrasound money. And I don't think that is at risk, because Ethereum still holds to be the settlement layer, which means that it will be the value layer, right? So in that kind of positioning, I don't think it's at risk at this point in time, at least. I don't know how things will pan out. In crypto, it's very hard to determine or at least predict future even. But that part I'm not very sure. So if someone is worried that Ethereum is losing its position in terms of DA, yes, but it has a DA-centric roadmap. EIP 4844 is coming. After that, the gang sharding proposal is coming. So we have a clear roadmap towards a data availability kind of solution. They are still going to be the dominant settlement layer, at least for the foreseeable future, as I see it at least. And then there are EVM-centric, like the execution engine, which has been debated a lot, right, till now. And those are the kind of things where there is a risk, but that's a good thing, because innovations are going to come in, new things are going to come in, and that's how we will keep on going ahead. But Ethereum has already talked about not execution scaling. So all of this just adds to its own thesis.
I think it's a spicy take, and it's probably 30 years too early I think the only L1 that could overtake or dethrone Ethereum settlement is Bitcoin because the cost of corruption is higher. But we'll say, I mean, go ahead if you have thoughts.
No, I think it's like, again, as I keep on saying, that we have to understand, like what you said is absolutely correct, right? That the cost of corruption, right? So at the end of the day, it will come down to cost of corruption. But what is it that you're corrupting? Also, the definitions will change. So Bitcoin, Ethereum, they have actually shown us the way, right? The Bitcoin has shown us the way how to even use blockchains, right? So, I mean, I still kind of sometimes open up the Bitcoin paper just to kind of, refresh my memory that we shouldn't forget how distinctive and how novel that entire paper was. And then Ethereum showed us that you can do so much more from this entire technology. So again, that is a huge kind of, headway that we have made from the two. But when it comes to technology, the only thing which we have to go on and do is that keep on understanding the notional changes that we are seeing as things change around us. And for the cost of corruption right now, it's huge, right? So on Bitcoin, it's huge. On Ethereum, that is huge. And that's great too. That's great to know. But then in the other constructions where the act of corruption is not has limited impact, I would say. So, for example, like if you today completely reorder, there's a lot of user value at risk. So even in DA layers, the corruption can be extremely dangerous, right? But at the same time, just because you can corrupt a chain doesn't mean that all the exchanges of the world will also accept it and so on. And I'm not a very big fan of, whatever I cannot handle in the protocol, let's throw it down to universal consensus, that kind of a world. But as long as like protocol guarantees are incentive compatible, it's very hard to corrupt a chain. And as long as we continue to do that, then we would have a very secure system, because most of the security will come from cryptographic and the less reliance will go on to cryptoeconomic.
Yeah, that was what you were saying earlier. It's a shift. Modular blockchains, they bring a shift from economic security to cryptographic security, which is very interesting. But I can't help myself because I'm really curious about the value accrual in the system. So let's forget Ethereum. Now we're looking at the stack. The typical stack is, DA, VMs, and settlement. So forget the settlement layer for now. We've got DA and we got VMs. I think that stack is expanded in first half of 2024 to DA, VMs, interop, and sequencing, and then perhaps more. You're shaking your head. So let's start with the first two, perhaps. How are we thinking about the value accrual here for each player in the stack?
I think you hit a very interesting point, is that the value accrual needs to be extremely well understood in order for each of these modules to be self-sustaining, right? There are different trade-offs there, and I keep using the word trade-offs as if to evade questions, but really, I don't want to use it that way. But let's think of specific parts. Let's say that you have a sequencer, right? A sequencer is extremely valuable business because it can capture MEV. Now, that kind of thing probably no one talks about today, but these centralized sequencers can capture a lot of MEV from the market, and they don't need to be bootstrapped. Even today, typical production grade sequencers capture, tens to hundreds of $1 million per year. So that's a very profitable business to run a sequencer, even without MEV. MEV is something that we are not able to see on the balance sheets, right? So that is a very profitable business. Now for the prover is the part which keeps the objective finality alive. You need only one correct prover in order to, secure the chain, right? Because once the sequencer comes in and publishes a particular batch, it's set in stone, right? So either someone comes in and, completely accepts it, or you just rerun it to accept it, that you know that it is correct. So for a prover, there needs to be incentive for someone to do it, just someone to do it. Right? So as long as there is at least one person who does it, it can be altruistic, it can be incentivized, it can be coming directly from the users. Even there are better constructions right now, for example, that are not in production today, but I think in 2025, we will start seeing things like client-side proving, right? Where the clients themselves will prove transactions. And then the operator will just kind of, aggregate proofs and such. So those kind of constructions we will keep on seeing, and those kind of where the value prop kind of changes, the value accrual kind of changes, because users then are more self-sustaining in that manner. The operator has a very stateless kind of a role in those kind of circumstances, but that's something that we will keep on seeing. In terms of, again, share sequences and such, not trying to tell about them separately, because again, they capture a lot of memory and they can give out a big part of it back to the protocol and things like that. In the end, the DNR is where the transaction costs come in, right? So the DNR is where the batches get submitted, and that's why it has a solid revenue stream that way as well. So overall, right now, what you see is extremely well delineated in terms of value. User pays a transaction fee to the operator. Operator either extracts more through the MEV or not. Typically, they don't today. At least that's how I like to believe it. Then take that and put it onto the DNR. For that, you have to pay a fee to the DNR. The DNR is where you derive part of your security from. So that's the kind of, subsidy, like that's a commission that you have to give to inherit the security, so to say. There's a proven which can be incentivized directly from the user, parts of it, or through the operator, or can be altruistic, or can be a competition-based system where there's a definite reward based on what you are looking at. There's proof of efficiency, there is altruistic behaviors, there are other kind of, typically a lot of research has gone on to that kind of system. And then they generate the rewards. It can be like whoever does it first gets most of it, or it can be all the people who did it well can get pie of it. There are problems with either one of them, but there are solutions as well. So you see that all the pieces till now, when I've talked about, have a solid, way to accrue value. There are other things which are yet to be kind of, seen. For example, there are separate services which run, let's say you are running an RPC. Right? RPCs are incentivized from outside the protocol, right? So the users pay the RPCs for API requests and so on. Sometimes RPCs, the subsidized costs for others and so on. So even when you use MetaMask, you are using an inferior RPC, your cost is being subsidized. Right? So those kind of models are also being seen. There are other models which will be seen in the coming future, which is that a service will actually subsidize the cost of user transactions. So as a sequencer, they will not take user fees. They will actually subsidize it themselves, because you would want a first-class Web2-like experience on Web3. You wouldn't want a wallet. You don't need a wallet for you to actually, sequence a set of transactions. So a lot of different types of use cases are going to come up, and we will keep on seeing how each one of them, have a value accrual. Even I'm also often looking forward to sometimes an ad-based Web3 front end. Maybe that's also that to see.
Yeah. A couple of things. First, say goodbye to those OP retroactive grants from the sequencer fee, boys, because those are being subsidized back to the users. So enjoy those while they last. The other thing is, just to confirm, when you say when a transaction goes from the user pays a fee to the operator, you're referring to the operator as like the execution layer, right? The execution environment like that. So whatever VM that is. So that's where you start, and it kind of trickles down all the way into the whole stack. So realistically, in the modular chains, it's every part accrues value. It just depends on the sequencer could theoretically accrue more than the rest. They do take a ton of MEV. But again, if they're subsidizing transactions, then there goes a lot of that kind of revenue or profit margin. So basically what you're saying is, as long as we have users clicking buttons, each part of the stack is then at least generating revenue to which then the expenses are obviously laid out on the balance sheet. And at the end of the day, we're likely, hopefully, in times of a lot of activity, running highly profitable businesses on chain, which is super exciting. My thought on the RPCs is this might be a tough answer, but you're RDA layer. You want to give the best experience for all users who use DA, Avail packed DA layers on roll. So you want to, if you're working with Gelato, Alt Layer, Nanier, OP Stack, whatever it is, you want to give those users the best experience. But there is now 50 rollups. There's soon 500 modules. Who's solving the RPC problem for all of these? Who's paying for that? And who in their right mind is indexing 500 rollups?
You're absolutely correct. And that is a problem that we think hard about. And that is why you will keep seeing our efforts in the coming days in order to solve that challenge. Now, to kind of give some of the insights on how we are thinking about it. Again, these are not solved problems, but let me just try to give a few ideas that we have been thinking, and then you can also think about it. The first is that RPCs, right? So one of the first and foremost things that we are trying to do right now is make our light clients the first-class citizens of our network without relying on RPCs. Now, we want to have minimal reliance on RPCs. Our light clients, and that's the kind of work, the bulk of work we have done in the last 2 years is on the peer-to-peer layer. Because, creating a system or creating a blockchain is not the hard part. The hard part is creating a peer-to-peer layer which is stable, which is dependable, and which is performant as well. So what we are trying to do on the light client side is that we are creating a network of light clients, all of which contribute to the security and the availability of the network. So every time a light client samples, it not only samples and just checks it themselves, but also puts the samples out there onto the DHT so that the next guy coming in doesn't have to pull from it RPC. It can pull only from the peer-to-peer layer. Even going one step up, we are trying to populate the DHT with all the proofs needed so that RPC reliance goes to a bare minimum. Only the header fetches can be done from the RPC. In the future, we also have plans to mitigate that in order to the light client to only have the RPC as a backup. Like only when the entire peer-to-peer fails is when they go on to the RPC. So that's the kind of things that we are trying to do on the DA layer. On the execution layer, you are absolutely correct that who in their right mind is like interacting with thousands of chains and still being able to, keep track of RPCs. What is down, which chain is up, what is happening, like whether I have a soft confirmation, hard confirmation, what is there. And in those regards, what we are trying to create in Avail is we are not only looking to build just a DNA, right? We are looking very hard at how we can create a very, composable kind of ecosystem around it. DA will become the centerpiece because that is where the security comes from. So DA is going to be our main focus as we have seen till now. But in this world, we want to make sure that the experience that the user has is the chain remains only a small fraction of it. And how we are trying to do that is, for example, suppose you interact with Amazon, right? And it's not that Amazon has payment systems element. What Amazon does is that when you click the buy button, it sends a call to a payment aggregator. The payment aggregator doesn't have any of your credit card information actually. The payment aggregator sends that to someone like, let's say, Visa. Visa doesn't know your account balance. So Visa sends that call to someone like your bank. Your bank is then fulfills the request. It gives back a call to Visa. Visa gives it back to your payment aggregator. Payment aggregator like Stripe, and then they give it back to Amazon. As a user, you didn't interact with all of these chains, right? You didn't interact with all of these applications, to be honest, right? Of course, the URLs changed, but you didn't put those URLs. And just like that, we are trying to scaling this entire thing up using asynchronous message passing between rollups. And that is something that we already have a POC for. We are not just talking out of thin air. We are working every day to make this a reality so that as a user, you would only want to give what you want to do. And the rest of it will be chain to chain level interactions, which the user don't have to actually go and do. So for example, there might be a payment chain. There might be a separate NFT chain. And all of these are application specific in our worldview. What that means is when it's application specific, indexing becomes less of a challenge. Because what is indexing, right? You have a shared chain and you need application specific information. And that is when you have to index it. Because you don't want this entire thing to come to you. You want to filter it and take only parts of it which are relevant. Think of a world where the applications are only serving one, right? The chains are serving only one application. Then in that world, indexing is the lesser of a challenge. I'm not saying it will obliterate the need for indexers. It will change the world how we see it. Not like that. It will happen delta by delta, right? But we are already working on features like that where you would want that, okay, if I want an NFT, I check out this chain. If I want to know my account balance, my accounts remain on this chain. And then I can interact freely between them. And there can be 3 or 4 other chains which serve only one purpose, but you don't need to know it. You just need to know that I have this bank card and I want this product from Amazon. Everything else will be taken care of. And that's the kind of power for this roll-up-centric ecosystem that we are trying to build.
Asynchronous message passing, interrupt into the conversation. Like that's where this comes in. And that's like the piece that we haven't talked about so much, but we had a great podcast yesterday with Hyperlane, who's building permissionless interop in the rollup space. And it kind of opened our eyes to this RPC problem, but didn't have a particularly great solution to it. I think the asynchronous message passing that you described is a very clear, tangible visualization of how we can picture how these messages pass through and through. And we were on a space like not that long ago, and there was some conversation between Hart Lambert from UMA and Susanna Evans from IBC talking about how right now value transfer is the only use case for message passing across chains. But what you're talking about isn't value transfer across chains, it's generic message passing. Am I right? Could you kind of like just illuminate a little bit on whether or not the messages that are getting passed across rollups include any value, or is it simply the message that is getting passed?
It's simply messages. And you will be able to see more. And I just don't want to paint picture in the air because I hate when people just talk hypotheticals. But what it will look like is even you will only talk about intent. I intend to pay up to this much in order to get an asset, right? And then there will be a chain which will run a solver, which will do the solving. Then there will be another chain which will find the actual chain where the asset is in the minimal priced or something like that. And then they will go to that chain, ask for that asset, and then they will realize that, oh, wait, I had, the user had the funds in USDC, but the asset can be only bought in ETH. So let's go to a swap chain where there is enough liquidity that I can get the best price and the lowest click rate. Let's go and convert it. Let's convert it, take it back, and then go to the asset chain, buy it, get the rest of it because value can be changed. So change the rest of it back to USDC because the user already had that, and then propagate that back. So it's all about messages at this point. and promises getting resolved. Because we have seen that in the Web 2, right? And of course, we can sit here and criticize a lot of the Web 2 design decisions, but there's a lot to learn from it. And one of the ways in which Web 2 was able to scale was through this asynchronous message requests, right? And the promises and resolutions that you see today on all API calls. The entire Amazon to your bank story, none of that was synchronous. None of that was done in a way where there was a synchronicity assumption, right? Every one of them were promises and then callbacks. So, or timeouts, right? So those kind of constructs we are trying to create, but the main difference being that this is going to be trust minimized. In Web 2 world, all of these were trusted. Like every one of these calls were becoming a call to a trusted entity. In our case, the main delta, the main difference is that even if there is a transaction inclusion, you can give a proof of transaction inclusion. If there was no transaction inclusion, you can give a proof of non-inclusion. So all of these, the relationships are not about trust. It's about verifiability. And that's why verifiability is so close to our hearts. But none of this actually work when you do not have a single DA layer. Because as soon as you cross DA boundaries, your security trade-offs actually change. Once you cross DA, your security zone, you have to cross it. And that's where you have to rely on someone else's cryptoeconomic security for you to cryptographically evaluate something. And that's what the kind of world we want to avoid. So we don't want to call these bridges, right? But they are essentially there. They are some form of bridges, but with much lower security assumptions, like trust assumptions.
Yep. Sovereign interoperability, something that you'll hear over the coming months. A little birdie told me about it, and we are coming up on time here. And I think yet the most important question for you, my good friend Prabal, starts with a W, sounds like Ben, and the question is, when mainnet, my friend? When?
So as Andy, you of course know that we are running our incentivized testnet. This is the final testnet that we are going to run before mainnet. Our mainnet plan is Q1 next year, which means it's just around the corner. We are doing final rounds of stress testing, different components, different challenges. Any of your listeners are free to join in. That is challenges for every kind of users. We are trying to accommodate as many validators, but there is also simple tasks like, balance transfer, and there will be other tasks about light client, running of light clients and so on. But essentially the target is just to understand if there are any vulnerability, anything that we have missed out, any last minute bug fixes and so on. The feedback that we have gotten till now, it has been awesome. And this is the last mile. And the last mile is always the toughest as well. So we're very close towards mainnet. Q1 is when we would launch our mainnet, barring anything significant that we come across on the incentivized testnet, of course. But that's the overall plan.
Beauty. Thank you, Prabal, for the time and for the diving deep into the weeds, the modular weeds. It's always fun. Cheers, man.
Thanks a lot for having me. It was great chatting. There were some topics which were a breath of fresh air because no one really talks about them. So thanks a lot. Thank you for having me.